Hello dear fans. Why the seasons change. Earth is an amazing planet. Its climatic zones are diverse, and the variety of natural phenomena some people are still unable to not only prevent, but at least predict, make it unique. Among other, sometimes catastrophic events, the change of seasons is a constant, familiar, and expected phenomenon. Why and how do the seasons change? Instructions. Step 1. As you know, the Earth constantly makes two different movements around its own axis, with a period of rotation of 24 hours, and around the Sun in an elliptical orbit, with a cycle of 1 year. The first ensures the change of day and night, the second the change of the seasons. The fact that the Earth's orbit has the shape of an ellipse and in its annual motion it periodically turns out to be at different distances from the Sun, from 147, 1 at perihelion to 152, 1 million km at aphelion, practically does not affect the change of cold and warm periods. As a result of this difference, the Earth receives an additional 7% of solar heat. Step 2. The angle of inclination of the planet's axis to the plane of the ecliptic is of key importance. The Earth's axis is an imaginary line through the center of the planet and its poles. It is around it that the daily rotation takes place. The ecliptic is the plane in which the planet's orbit lies. If the Earth's axis were perpendicular to the plane of the ecliptic, the change of seasons on the planet would not occur. They simply would not exist. The Earth's axis is at an angle of 66.5 degrees to the plane of the ecliptic and is tilted from its axis at an angle of 23.5 degrees. The planet maintains this position constantly, its axis always looks at the North Star. Step 3. As a result of the Earth's orbital motion, its northern and southern hemispheres are alternately tilted towards the Sun. The hemisphere, which is closer to the Sun, receives 3 times more heat and light than the opposite. At this time it is winter, there is summer. Step 4. The Earth continues to move in its orbit, maintaining the angle of inclination of the axis, and the situation changes. The other hemisphere is now tilted towards the Sun and receives more heat and light. Summer is coming. Step 5. But the difference in distance to the Sun also has some effect on the Earth's climate. The southern hemisphere is closer to the Sun at the moment the Earth passes perihelion, the point closest to the Sun in the planet's orbit. Therefore, the southern hemisphere is somewhat warmer than the northern. In turn, the northern hemisphere is tilted towards the Sun at aphelion, the farthest point of the orbit. Despite the fact that it is summer in the northern hemisphere at this time, the temperature there is lower than in the southern hemisphere in summer. Step 6. In its orbital motion, 2 times a year, the Earth is in such a position when the Sun's rays are practically perpendicular to its surface and the axis of rotation. March 21st and September 23rd are the days of the spring and autumn equinox, when day and night are almost equal in duration. At this time, the Earth crosses the celestial equator, and passes from the northern hemisphere to the southern hemisphere, or vice versa. It is on the days of the equinox that the astronomical change of the seasons falls. Step 7. The moments of equinox are annually shifted relative to the beginning of the day. In a normal year, it occurs 5 hours 48 minutes 46 seconds later than the previous year. In a leap year, earlier by 18 hours 11 minutes 14 seconds. That is why the equinox sometimes falls not on the indicated days, but on the calendar dates adjacent to them. Thanks for watching.